All right, we're going to start out with a pretty simple subnetting problem, a Class C network. I'm going to give you the whole network to use to make it simple. And don't let subnetting be one of those things that scares you. It's just something you have to practice. And we'll start out with a simple diagram here. We'll say this is a router, and attached to this router are two switches. If you can read my writing here, the screen's a little tricky to work with. And each of these switches must support 30 hosts. I say host, I mean a PC or some other type of networking device such as a printer or even our copiers these days. A lot of them have network ports. Just something that has a network card that needs to be hooked to the network. Now, based on that diagram, and we're not going to worry about how the router is fed from a gateway. We're going to ignore that for the moment. And we're going to say there's only two networks here. This network and this network. Two networks. And the first thing we need to figure out is we need some information, right? We need a network address. What are we given to work with? Let's say we're given, this is what we're given to work with, 192.168.1.0 with a subnet mask of 255.255.0. Now remember what ones mean in a subnet mask. This is all ones. A 255 is 8 binary ones in a row. And a 1 means it's a network bit. A 0 means it's used for hosts. That's really all it means. They always need to be contiguous. All the ones are together like this. All the zeros are together. Now, they may be partially across an octet. This one could be split, for instance, but they're all together. So all the ones are network bits. All the zeros are host bits. That tells us that the last octet is all host bits. So this is the octet we have to work with. We know no matter what else that we do with this problem, we're going to have 192.168.1 as the first three octets. Whoops. We'll have this last octet as something we can manipulate to create a subnetwork out of. Now I'm going to give you a few rules, and then we're going to come back to this diagram. Here's a few steps, you might say. You could break down each subnetting problem in steps, and this is how I like to do it. It's a technique. It's nothing required, but this is how I do it. First of all, how many networks do I need? And again, you have to pardon my writing. It's a little difficult to write with this screen pen. How many networks do I need? That's a question you need to ask yourself pretty early in this process. It loves grabbing my page index over there. How many bits will I borrow? That's the next question. And I say borrow, I mean borrow for subnetworks. How many bits will I borrow? At that point, you will know how many bits remain. That's supposed to be 4. 4 hosts. How many bits remain for hosts? In other words, if I need 30 hosts per network and only have enough bits for 20 hosts, or let's say 14 hosts per network, I don't have enough bits left. I either did the problem wrong or they're asking me for something that can't be done. So that's the next question you need to ask. And underneath that question, what we just said, is there enough left for the hosts? You'll also, somewhere along the line, you'll want to know what is my new subnetwork mask. Or subnet mask. And one of the problems I typically ask students to solve is, what is the first network address, what is the first host address, and a myriad of other questions. So from this point, once you get this set up here, you can just generally solve the problem, whatever it is. Whatever it's asking you for, at that point, you're able to solve the problem. So take your time and break this up into tasks, and ask yourself each of these questions, and you're going to find it to be a little bit easier as a starting point. All right. Let's take a look at an example. Okay. Give it a few seconds here for the screen to stabilize. All right, let's take a look at an example. You've been given 192.168.1.0 as your baseline address, and from that you're supposed to create a subnet to support 2 networks with 30 hosts on them. So let's follow our rules that we initially described. First of all, how many networks do I need? And the answer here, clearly, there's 2 drawn, and that's all I need in this particular case. I need 2 networks. So if I need, let's use 2 as our starting point, how many bits do I need to borrow, and from where will I borrow them? This part of the address is fixed because this has already been defined as network address by the first 3 octets of the subnetwork mask. So I simply can't mess with any of this space here, the 192.168.1.0. The last octet has zeros in the subnet mask. Because of that, the whole octet is in play, let's say. So I represent that. I blow up that 0 from decimal. I blow it up into binary. Of course, X's are not binary. I'm just using that as a placeholder. One other thing I like to do, and it's technique only, it doesn't matter, is I like to put a little gap between the 4th and the 5th bit just to group things into 4. Maybe it's because I have a hexadecimal background with things, but I like to do that because it's a little easier on the eye to determine where the positions are. Now, the one thing about subnetworks is when you're borrowing subnetwork bits, instead of moving in this direction, we generally kind of work our way in this direction. By that I mean if you borrow 1 bit, you're borrowing here. If you borrow 2 bits, you're borrowing here. If you borrow 3 bits, you're borrowing to here. It just depends on what you're doing. Now, the normal number line in binary, if you would write out a number line, and I suggest you do until you get very familiar with it. Looks like that. But if you borrow the first bit, you don't get, if you borrow this bit here, you do not get 128 subnetworks. You only have 1 bit you're working with if you do that. So you only have a possible combinations of 2 subnetworks. All right, and because we don't use the subnetwork 0, at least for now, and we don't use all 1s, we throw out 2 networks every time. So as you should have seen in the lecture, the formula for determining subnetworks is to take the number 2, raise it to a power, and subtract 2. Now, what is this power? That's the number of bits you're borrowing. So the number of bits you're borrowing determines how many networks you can support. If I borrow 1 network, 2 to the 1 is 2 minus 2 equals 0 usable networks. Obviously, that's not going to work for us. If I borrow 2 subnetworks, 2 bits, I mean, how many subnetworks can I support? Well, that would be 2 raised to the 2nd power, which is 4 minus 2, and that equals 2. If I borrow 3 bits, that would be 2 to the 3rd, which is 8. 2 times 2 is 4, times 2 is 8. 8 minus 2 is equal to 6. Now, that's the formula for doing it, but you really need not know any formulas because we only deal with 8-bit numbers in binary, and sometimes, not to get too far ahead, but when we go what's called across the octet, there's only a few times you'll do that. Really all you have to remember is kind of these numbers over here on the right. If you borrow 1 bit, you can support 0 networks. So 1 bit supports 0 networks. 2 bits supports 2 networks. So 2 bits over here equals 2 networks here. 3 bits will support 6 networks. And you should be able to see that 4 bits, 2 to the 4th would be 16, minus 2 would be 14 networks. 5 bits would be 30. 6 bits would be 62, and so forth. So if you just want to build a little table like that, you can just do that if you don't want to work with exponents. Actually, after a while, you'll just simply memorize the numbers. There's only a few involved, so it won't take long to do. If you don't worry about it. Just build you a little table like this. All right. Okay, as you can see in this example, we need 2 networks. So how many bits will we borrow? Well, if we borrow 1 bit, that would be 2 to the 1st power, which is 2 minus 2 networks equals 0. If we borrowed 2 bits, both of these bits, 2 squared would be 4 minus 2, and that would be 2. That would provide us with the 2 networks necessary. So let's borrow 2 bits. Now let me erase this and redraw this over in the center of the screen just a little bit better. I hope you're taking notes. Okay, this is the 8 binary digits, or placeholders for the 8 binary digits for the last octet of this address. We're going to borrow 2 bits. Now, let me go ahead and change colors here for my pen a moment so you can see this red line that I'm going to make. And what I draw that down there for is so I can keep the notion that my network bits are on this side of the line and my host bits are on this side of the line. Okay. All right, now let me change my pen color back here. All right, now we count in binary. We're going to start at the smallest numbers and work our way to the larger numbers to determine network addresses. The first thing we do is we'll use zeros here. And when we're determining a network address, we're going to set all our host bits to 0. And let me draw you a number line out here too, since you may not yet be very familiar with binary. Each of these numbers is weighted to this value in decimal. The problem is this network is a 0. It's all zeros here. And we don't use the 0 network at this time in your training. So this is one we're not going to use. This is an unusable one. We throw out 0, we throw out all 1s. All 0s, all 1s we're not using for now. The next network address, now we would have any number also of combinations of 1s and 0s in the host bits, but for now we're not going to worry about that because we're not going to use this network address here. There's no need to worry about what the host bits would have been. So let's go to the next network position. We're just going to count up in binary, treating these 2 digits here, the first 2 digits, like they're separate from the rest of the number. So the next, if 0, 0 is what you start with, the next number is 0, 1 in binary. So 0, 1. And the host bits will set to 0 while we're determining the network address. So what is that address in binary? It's 192.168.1 dot, and if you look, 1 is in the 64 column, 1.64. And the subnet mask is 255 dot 255 dot 255. And how many bits did we borrow? We borrowed 2 bits. And remember, in subnet mask, if you're working in this direction here, and the first bit is 128, if you borrowed 2 bits, you would add the 64 place to it, so you would get 192. Borrow 1, you borrow 2, it's 192. If you borrowed 3, it was 224, and so forth and so on till you get the 255. In this case, we only borrowed 2 bits, so the subnet mask is 192. And what does that tell us? That tells us that the first, second, and third octet are all 1s. That means they're all network bits. And in the last octet, the first 2 bits are network bits. And that's what we've been doing, and that's okay. Now, what is the first host address? Okay, the first host address, now, when we're still on this network, we're still on the 01 network. The first host address would be 000001. And that would be 192.168.1.65. What would the second host address be? Now, keep in mind here some things. This is the first network address. This is the first host in the network, first network. So we would probably assign, if this is the first network up here on the router, this is probably what we're going to consider the first host, the actual router interface itself. So we would probably assign the 192.168.1.65 IP address to the router's interface. Now the hosts down here on the network also, these 30 hosts are going to require IP addresses as well. So the second IP address, again, we're just going to count in binary. The next number here, we've got 01 here now. The next number would be 10 in binary. And that would be 192.168.1.66. And of course, out here, this network address hasn't changed. So it's still 01. The next host address would be 01.00.00.11. And that would be 192.168.1.67. And that would be the second host. I mean the third host, excuse me. There's the second host. So if we had PCs out here, we would start assigning those IP addresses to those PCs, either through DHCP automatic or statically, meaning we go to each machine and set the IP addresses to those values. All right, I'm not going to keep counting up in binary, but if we did, it would be 100 for the next host. In other words, would be 0100. So the next host would simply look like, as we count up in binary, and that would be .68. As you can see, we're just going to sort of count up until we fill up the host portion of this address. As I'm running out of room here, let me go ahead and pause and clear this screen, and you can continue on in your notes, certainly without doing that. So let me do that. Okay, I tried to reproduce the last little bit right up here at the top. The first network address usable, remember, was .64. The first host address is 65, and we had shown you that 66 and 67 and so forth were the next few. Now, we would continue counting up in binary in the host range to determine those next few host addresses until we filled up this field of 6 bits. And again, remember, one of the questions I asked was how many host bits remain after we do this process. We borrowed 2 subnet bits, 6 host bits remain. So 2 to the 6, by the way, and you'll start getting a feel for this soon enough. 2 to the 6 is equal to what? 64, right? 64 minus 2 is 62. So 62 hosts could be supported on each network. How many hosts are required on each network? 30. So because only 30 are required and 62 could be supported, we're in good shape. So let's keep solving this problem, and let me ask you, let's say the problem is this. I want to know what the last usable host on the first subnet is. This is the first subnetwork we're working on. What is the last host? Well, we would keep counting in binary until we got to what? Until we got to 1, 1, 1, 1, 1. And if we did another 1 over there, now that would be the biggest number we could support. Now, when we get to all 1s in the host field, that's the broadcast address. Remember, 255, 255, 255, 255 is a subnet mask, is a broadcast address. So when it's all 1s in the network address, that means it's broadcast address. So we're not going to use broadcast as a host. So if the maximum number in the host field is 1, 1, 1, 1, 1, 1, that means the one prior to that would be 1, 1, 1, 1, 1, 0. Now let's see what that number is in decimal. There's a 0 in the 1s column, so we don't need to add that. There's a 2 here, so 2 plus 4 is 6, plus 8 is 14, plus 16 is 30, plus 32 is 62. 62 plus 64 is 126. Of course, I don't expect you to do those in your head. I expect you to do them on paper. I just don't have any handy. So 126 is the last host address on the first subnetwork. So in other words, that's the highest value I could give to one of the PCs or hosts over here on this network here. Because the next value, 11111, is the broadcast address. Now notice there's about 62 addresses between the network address and the last host address. That makes sense because look what bit we are incrementing on for networks. We're incrementing on the 64-bit. So because the last network bit is the 64-bit, we'll find that between each network address there's exactly 64 hops or 64 addresses. Look at the broadcast. That's a .127. That would be 192.168.1.127. That's what this network here would use for its broadcast address. In other words, if a PC needed to broadcast to everyone on its subnetwork, it would use that address, .127, and everyone would listen. Now, what's the next network address? Let me block this off. That's the first network. And notice there's a gap between here and here. We didn't write down every PC value or every host bit value between 65 and 126. That would take some time. But obviously all we're doing is counting up in binary until we get to 126. Okay, the next network address. The first one was 0 and 1. What's the next number in binary if you're dealing with 2-bit numbers? Well, it goes 0, 0, 0, 1, and then the next one is 1, 0. And the last one, of course, would be 1, 1. But 1, 0 here. Okay? And incidentally, that 1, 1 value over here is unusable. That's the broadcast. That's where you get the, when you're borrowing bits, you get the 2 to the n minus 2. 0, 0 is one of those, and 1, 1 is the other in this case. So those are the ones we're throwing out. So the usable networks in this case would be 0, 1 and 1, 0 in binary. And the last 6 bits, again, are host bits. Remember I told you when we're determining the network address, we'll go ahead and set the host bits to 0. And what is the address? It's 192.168.1 dot what? Well, the 1 is in what? The 128 column here. So, and that's the only one. So that's 128 is the second network address. Notice the increment between 64 and 128 is the increment of the last subnetwork bit. So you can check yourself that way. If 32 had been the last bit, we should see 32 addresses between the first network address and the second network address. In this case, the increment was on the 64 bit, so when we use 64 as the first network address, we should see another 64 to the next one, and we do. 64 and 64 is 128. That's the second network address. Now allow me to reset the screen here, and we'll work that one through. Okay, I reset the screen here so that you can see this a little bit better, hopefully. The first network address is 00, and that's unusable. The second network address, first usable network address is 01, and that forms 192.168.1.64 over here. And the first host address is .65 like we discussed. The last host is .126 like we discussed. And the broadcast would be 127, because when we add this whole range right here up, that's what we get. And I just use .127 so we don't have to keep writing 192.168.1, because that never really changes. So this next network address would increment simply off of this binary sequence here, 01, and that becomes 10. And that, of course, is, when you do the number line, that, of course, is 128. And we set the host bits to 0 when we're determining the network address, all the way across to here, and that becomes .128. That's not a host address, of course, that's the network address. Now, to be useful, we need to have host addresses. And to do that, we use the host range of what's left, our 6 bits of host bits that are left, and the first one is 000001, and that is .129. And that becomes the first host on the second network. Very often what I'll ask you to find, and some other instructors as well, will be to find the network addresses, the first host address on each network, the last host address on each network, and the broadcast address of each network. And that way we know that you have the process down. And again, this is going to take many attempts before you finally get this. Be very patient with yourself. Be very patient with me as we explain these things. Keep going through the examples. Pause the videos if you need to. Stop and try to get a hold of it. Keep going if you don't understand something sometimes, and just try to keep going through the examples, and hopefully it'll click in. If not, you can always come see me, and I'll sit down and try my best to explain it to you again. So the first host is .129. What is the second host going to be? I'm not going to write it down, but it would be 000010. That would just simply be the next number in line, and that would be .130. Now, I would continue on like that, going through the host, counting up these host bits until I got to close to the end. And one thing you notice, the last host, what did the form look like? In other words, all the host bits were 1, and I'm circling up here in red. When I was determining the last host on the first usable subnetwork, it was 11110. And that form will be the same for the last host in all subnetworks. Now, if there's more bits out to the left, there'll be more ones, but the form will be all ones up until bit 1, and that'll be a 0. So that's always the form for the last host. So that's going to be 11110. Now, what's that number going to be? Well, that number is going to be, you're going to need to add up a 128, 32, 16, 8, 4, 2, and of course 0. You don't need to add it. And if you add that together, and you can do that, you can pause the video and do that on your own if you need to, is .190. And that will be the last host. Now, is it right? Well, I know it's right because the increment between my previous last host, assuming I got that right, and this last host, the difference is 64. Is 64. And that's what I'm working on as the increment here, so I know that that's correct. But let me get the broadcast address. Now, the broadcast is just going to be one more. I know that. So that's 191. We just filled in the last bit. So that's a broadcast. Now, is that an increment of 64 from the last broadcast address? 191 or 127 plus 64 would be 191. That is correct. So that's the second network. Now let's say this is the second network up here, up at the router diagram. And I would probably use 129 as the router interface address and start using the other addresses as this host range out here for each of the PCs. Again, either automatically or setting them manually. I would set those addresses. Now, what would the next network address be? Well, the next network address would be 11. But that's all ones for the network. And when a network address has all ones in it, it's a broadcast, and that's not usable. It's like the 00 up here. So these are the two addresses that are not, or two networks that are not usable in when we were borrowing bits and we did the 2 to the n minus 2. That's where the minus 2 comes from, those two. All right, now that's the first example. We're going to have many more examples. Work through this one. If you're not catching on to everything, don't be hard on yourself. Give yourself a break, and we're going to work through at least 10 more of these. So take your time, be patient in learning this.